So Hans-Jörg, welcome here. Thanks a lot for taking the time for being here and for presenting the fourth market report. It's already the fourth one. I was really surprised that we're already in it for so long with this document. It has been a very important one from the start, and it's gaining importance with each time. And I would also say it's gaining quality each time you present it. Now we're launching our market report today. It is on the website, can be downloaded. The link will be shown. The data has already also been taken up by the IBI market report, which will be launched tomorrow, and by the State of the CDR report, which will be released in June. So it has made itself heard, and we're in dialogue, of course, with people all over the world. This is also why I have to say good morning, good afternoon, good evening, good everything as far as I see, because it seems like we do have people from all over the globe here. I don't want to take too much time. I'm grateful that you're here, Hans-Jörg. So we're now listening to you and we're interested in, well, the new developments and some news about biochar carbon removal and the potential that it bears. Please share your screen.
Yes, please. So, welcome first from my side. I'm glad that there's so much interest in this market report, and I'm really looking forward to also see discussions on LinkedIn, have discussions here in that circle, and yeah. So now just going directly into the report. So we're going to go into the fourth market report, 2023-2024. And as in the last year, I would like to do an introduction, highlighting some sector trends, and also have a major topic that is BCR's role in the net zero pathway. I think this is a really important topic, and we're going to highlight on this in this report. So directly into the highlights, and I have to start with the great success of CRCF that ended in February 2022, that included BCR into the industrial permanent carbon removal bucket. And that was really, really important because the CRCF carbon removal certification framework, that is probably the most advanced system for carbon removal, and it will rule all CDR activities in Europe. And it has a strong lead to also other regions, because carbon removal markets are global markets. And the great success is that CRCF ended to be technology neutral in its definitions, and biochar is included in all three of the relevant fractions. So huge thanks at this point to the EBI policy working group, but also mainly to Harald, who is part of the expert group in the EU, and Thomas Hemmerle, who did an awesome job. So that was really a huge achievement. And this is really good news for the climate and for the whole BCR community, from researchers to commercial people. So another highlight I want to mention is Denmark. Denmark has developed really into a front runner in biochar carbon removal, and they've set up a target of 2 million tons of CO2 to be annually removed by 2030 with pyrolysis. So there's really an exciting study that was published by SIP Fonden, and that is summarizing the strategy of Denmark that has been adapted into scaling biochar carbon removal. Another highlight, I would say, is the development we see in sewage sludge. EBI is on its way to publish a position paper, because we are seeing a lot of activities in the EU on incorporating sewage sludge. That is fertilizer product regulation, that is the wastewater treatment regulation. And as EBI, we are pretty active to provide the relevant and new information. Another sector trend, I would say, is that urban soil applications of biochar are becoming increasingly adopted, I would say. There was a concept that is long known to be used in Sweden, but we now see that it is increasingly adapted in Austria, Germany, Switzerland. And I was personally also kind of digging deep into this topic. And it's really, really exciting because it covers a lot of different needs of the city. That is cooling the city down. It is stormwater management. So really interesting topic and a clearly growing market. Then I'd like to highlight quickly on a trend we also clearly see, which is that biochar in concrete is expected to be a major market driver. While in the last years, the market was mostly driven by pilot projects, we are now seeing first commercial projects and products. And the market for biochar in concrete has the potential to take up really very, very large volumes. And many of our EBI members are increasingly focusing on this market. And another new market, if you want so, is the metallurgical industry. And I've highlighted here in that slide what it is about. I mean, we need, as a society, we need steel and we need a lot of silicon. And last but not least, because we have to grow the energy system to wind and a solar-driven industry. And for wind, we need steel. For silicon modules, we also need steel, but also need silicon. And these two materials, in case of silicon, it's just required that you need carbon to reduce the raw silicon production to get the oxygen out. And of course, this is not carbon preserving, but the situation here is that you need carbon, and it's either fossil carbon or it's biogenic carbon. And we see an increasing number of members also focusing on the market of using biochar in the metallurgical industry. And then something I've been personally very active, that is permanence of biochar, as the last topic I want to discuss here about highlights and trends. And I've been working very, very closely together with Harald Bier on managing a multi-stakeholder process of discussing this topic of permanence of biochar with a review board of very knowledgeable people in the space. And I mean, the initiation was given by two groundbreaking papers that were both published in January. I think it was within a week or two. The one paper is Sané et al., and the other paper is Asi et al., both 2024. And bringing the views on these two papers together in a report was the exciting topic we took up with that report. And just to put one highlight, which is that we really have to look at biochar as a composition of different fractions of materials that have totally different behavior in decomposition, particularly totally different behavior when it comes to microbial decomposition. So we really have to look at these fractions. And the report also gives I think, pretty comprehensive summary on how we should take and how we can take the historic incubation experiments. So if you don't know the report yet, I can strongly recommend it. And also here, please put up your questions in the respective chats when you have questions about this. The main take on this report is that, or from our work, is that the fraction that is composed out of highly fused, high percentage of, or which is basically fused aromatic rings, which is called inertinite biochar, that this material will not relevantly degrade in soils over climate relevant periods. And yeah, so take a look at the report. Looking forward to further feedback in the discussions. Now I'll come to the point of biochar carbon removal's role in net zero pathways. And as many of you might know, I do have an energy background, worked for 10 years at Fraunhofer, worked another 10 years as a solo entrepreneur, working on defossilization. So this was really kind of a hard topic for me to look into the energy side of biochar. Now, we know all this slide, and we kind of know also the challenges, which is on one hand, we need to cut emission by 90%. And at the same time, we need to scale carbon removal by a factor of 5,000. That is just huge. That's amazing. That's very challenging. And I've composed a tongue twister, which I will now give in German, which is, wenn wir die Emissionen nicht senken, können wir uns das Schaffen von Senken auch schenken. So for those who don't speak German, this might just have sound totally weird, but what it says is, if we don't cut emissions, carbon sinks, or creation of carbon sink is basically irrelevant. We can't make hold of, if we don't cut the emissions, we can't solve it with carbon removal. And in that context, I would like to invite to take a side look on biochar carbon removal in the following way. Well, this is all what we know, that we have biomass, there's a technical machine that produces electricity, renewable power and heat, and it produces biochar. And as I showed, it can be used either in the metallurgical industry, or it can be used in a carbon preserving manner to make carbon removal. Now, if we relate this to the previous slide, we see exactly that whatever we do within this pyrolysis plant, it pays in either on the one side of the coin or on the other. So, and that in a way is unique for biochar carbon removal, that it pays in on both sides. And I'll show you a bit on what this means in numbers. And I mean, with my background in energy, and everybody who really looks deep into energy, electrical energy, knows that it will be the massive expansion of wind and solar that will have to drive defossilization of the electricity system. But defossilizing the heat sector and replacing fossil coal in metallurgy is certainly the bigger challenge than the electricity system. Now, when we look at the 6 most relevant carbon removal options, there are 3 of them where there is a close correlation between energy and carbon removal. And this close correlation between the emission side and the carbon removal side, this has to be incorporated into the definition of sensible net zero pathways. What do I mean with that? If we look at the energy system, so on the left, you can see a map of the carbon footprints of the European countries in terms of, so the unit here that you see in the slide is gram CO2 equivalent per kilowatt hour electrical power. So what we see here, well, number one, we have a huge span between 29 and almost 800 grams per kilowatt hour electricity. And we see that the average, that's shown on the right, the average on electricity in Europe is around 225 grams per kilowatt hour. So if you switch on the light, if you put on your water cooker, this is what happens. You add a kilowatt hour, and then it adds a certain footprint of the electricity. So we have an energy system that has a today's footprint, but this footprint has to change and will change over time. And the numbers you see here on the left, the footprint of the electricity is the EU targets for 2030 and the EU target for around 2035, 2040. And you see that this evolution over time changes the footprint, and it will also have to change the footprint of the heating. The heating assumptions are working assumptions here, but they're pretty reasonable. Now, if we look what this does to certain key technologies that are supposed to sequester CO2. So what you see on the left is pyro and power, that's pyrolysis with power generation. The next one is pyrolysis, then we have BECCS, DACCS, and fossil CCS. And you see that, I mean, all of the carbon removal technologies, well, the metrics we are looking at here is CO2 effect per ton of captured CO2. So by definition, all of them have 1 ton of CO2 sequestered. But then pyro and power and pyrolysis add quite a relevant amount of energy co-benefits, as much as BECCS does. And DACCS, but even more the fossil CCS, they have kind of energy disbenefits, or I don't even know what the word would be. And in summary, we can say that the BCR options have always the highest net CO2 effect per ton of CO2 removed. And this is quite relevant. Now, that's certainly not the only matrix to look at. Another matrix to look at is biomass efficiency. So we're now in the matrix net CO2 effect per ton of biomass. And here the BCR options are roughly in the range as the bioenergy systems when we are in a scenario of Europe today. And the BECCS system has a higher CO2 effect per ton of biomass because you have typically CO2 sequestration rates about 85% or so. And with biomass, you're producing more energy with BCR, you're producing more energy relative to the biomass. But when we look at the energy system evolving from the today's carbon footprint into the target for 2030, then BCR becomes continuously more advantageous compared to the bioenergy options. And once the energy system is mostly defossilized, we basically have 3 levels. One is the bioenergy, which then does not have anymore such a high benefit. The BCR options are clearly better than the bioenergy systems, and BECCS remains the highest level of biomass efficiencies. But at the same time, there are significant infrastructure challenges, including CO2 logistics, and BECCS also is probably mostly favorable for very large installations, and that comes also with infrastructure logistics to the biomass transportation. And BCR is a good option when either for economic reason or for infrastructure requirement, that would be BECCS would not be suitable. And this clearly shows, and by the way, yes, BECCS and CCS can also be combined, and we're seeing first projects in 2020 starting construction in 2024. So what I wanted to say here is that BCR is really a no regret solution, as it contributes both to carbon removal and to emission reduction, and on the very important topic of industry and district heating. And we have to be very serious about looking at portfolios. So we have to come to a point that we're really looking at where is the sweet spot of which technology in which place and at which point in time. And because I'm totally convinced that it only a portfolio approach can bring the solution. And we're now working up, setting up a project to make such a sweet spot analysis for different CDR technologies, together with Fraunhofer, Carbon Future, EBI, and 3E. Tim Meyer, a very experienced energy expert, and we're working on setting up a more deep insight study. And thanks again, Carbon Future, who allowed to share some of the results that have been worked out in a privately funded study by Carbon Future. So, quick update on EBI membership, and I believe very brief here. A simple message: we've now grown to more than 100 members. I think today's number is 106, quickly growing. And I would clearly say that we are at the point that the vast majority of the relevant players in BCR are members in EBI. Thanks a lot to all our members. Through the membership, we can do what we are doing and supporting the industry. Quick shot on what are the membership structure? What does the membership structure look like? We have about 25% of the members are manufacturers of equipment. There's something like 35% that are plant operators, either already today operating a plant or about to do one, to install one. And then the last big block is service companies, from project developers over carbon removal companies, certifiers. And so I'm really proud that we have such a great membership, and thanks again to the members. And working on 4 main activities: policy, communication, industry standards. And today's topic is market intelligence. And we're now coming to the heart of the market report. And I will skip motivation. You will be able to download, or you are report. You can see all the motivation methodology tasks. And I'd like to first thank the co-authors of this report, Harald Bier, obviously, Matthias Gustafsson, the Nordic Biochar Network, all the equipment manufacturers and plant operators that provided information to this report. The EBI Policy Working Group was also partly involved here, and then many other EBI members and stakeholders. So thanks a lot for this support. And thanks a lot to our sponsors, Carbon Removal Partners and Carbon Drawdown, and Carbon Future for sponsoring this year's report. And now we'll start with the overview on manufacturing equipment producers. And let me first say that this has been really developing impressively, how the technology providers have both grown in numbers, but also grown in maturity. We clearly see many of the players now at TRL 8 or TRL9. So look at the definitions on Wikipedia or wherever. This is clearly where biochar producers are today. There are producers that have installed several dozens of systems, and that is clearly TRL9. And yeah, really impressive how this development was. And it was so fun putting the pictures together, discussing with the equipment manufacturers about their progresses in the context of this market report. And I'll just skim over the slides. So when you are looking for manufacturing equipment because you want to install a pyrolysis plant, go to the suppliers directly, ask for their collaboration, and yeah, very interesting development what we saw here on the equipment side. And the list does not almost seem to end. I will not name them individually, but you have all this in the report, and you can then contact the equipment manufacturers. And I'm sure that this list is not exhaustive, and it will continue to grow. So clear trend was that the number is growing. Yes. Then I would also like to highlight that we are now seeing increasingly a new type of companies that has become project developers, system integrators, and system operators. And here are just 5 examples of companies that have already installed large biochar projects with equipment, partially from members, partially non from members, and partially internationally, beyond Europe, and really interesting dynamics. And this is what we will need to see. More companies that take it. This is what I saw in the development of the solar business, that you have professional project developers. We need professional financiers, and we also invite financial companies to join EBI, because we will only make this to climate relevance together, from equipment manufacturers over system operators into the financial industry. And now I'll come to the numbers of 2023-2024 market report, starting first with the annually installed systems that have been installed. Quick reminder, we're only counting systems above 200 tons annual production of biochar. And what you see here is 2023, we have a net increase of 41 systems that have been installed. It was actually 48 systems that have been installed, but 3 of them were permanently decommissioned. These were early installations, and 4 of them were relocated to another site, which is also kind of due to the fact that these were maybe sometimes the first or the second of its kind installations, and therefore these systems had to move. So net increase 41 systems, and for the next year we have 51. In the last year report we had 51 systems on our radar where we thought they would be completed this year. We saw that 2 of these projects on the list last year will not be built at all, and 5 projects slipped to 2024. So 2024, with the new data, we're now expecting 54 projects to be completed in 2024. So these are projects that are either under construction or under contract, and by the way, some of them are even already fully commissioned. And that brings us to a cumulative view of the installations in Europe to a number of 171 that were installed end of 2023. And we expect this number to grow to just over 220 installations by end of this year. What also changed kind of from last year, we've more focused on also involving the numbers for 2025. And there's a clear trend that the size of the projects will slightly further increase, and that some of the projects, or there's a relevant number of projects that are in an advanced planning or even permitting process, or even contracting process. So I'm pretty confident that 2025 there's a strong pipeline for 2025 installations. Now, coming to the production capacity. So what is here is the cumulative installed production capacity, which grew by end of 2023 to 75,000 tons production. This is dry mass. And we expect this number to grow to just over 115,000 tons production capacity end of this year. Now, let's look at the important topic of the growth rates. So we saw a growth rate from 2022 to 2023 of 41%. So it's slightly lower than the last year and certainly lower than what we had expected, but that was due to two relatively large projects that slightly slipped from Q4 to Q1 or Q2. But what is still really impressive is that we have an annual growth rate of 54% between 2020 and 2023. And based on the project pipeline, we expect the growth rate from 2023 to 2024 to be at 55%. Now, as I said, that was production capacity, and in order to assess the real production, the actual production, we already used since a while the approach that we say in the commissioning year we assume 6-month operation and a 60% uptime, and for the later years we use 12 months operation and 80% uptime. And with this method applied, we end up with an estimation. It clearly has to be said that this is an estimation, but I'm very much convinced that this is a very good and solid estimation of 49,000 tons in 2023 to grow to 70,000 tons of biochar in 2024, with 130,000 tons of CO2, respectively 200,000 tons of CO2. So with that, and that is no surprise, because that is also is clearly shown in CDR FYI, that biochar carbon removal is today's most relevant industrial carbon removal technology for permanent removal. Now, a few further insights into the structure of the production capacities we have around. We see a trend to more large and very large projects. In total, the categories medium, large, very large make up almost 80% of the production capacity. Coming to the distribution of where are the production capacities installed, we still have about 70% of the total production in 3 regions. Germany, Nordics, Austria, Switzerland are still the dominating areas. And we clearly saw that from 2019 on, the Nordics have become showed the strongest growth, and already now Nordics is the most relevant region, with Sweden, Denmark, Finland being the most relevant countries. But we also see that the other countries are steadily growing, with Spain, France, and UK being the biggest contributors to the strong growth. On the carbon removal standard side, we have a situation with clear dominance of 2 relevant carbon removal certification frameworks or systems, standards. EBC, EBC C-Sync and Puro Earth are the clearly dominating systems. And on the material side, so about certifying the biochar itself, it's a very, very clear domination of EBC as the leading material standard. So just a few trends and observations beyond the general growth. The first one is the CO2 certificates have become just an indispensable element of the whole business in the carbon preserving applications. But still, what I found surprising is that only 75% of the production capacity is certified carbon removal. There are some companies that just don't do it because it's they haven't known yet, so there's huge potential to grow that. But also some say, we're going to first install the system and then we're going to take care on the carbon removal topic as a next step. Then clear also feedback from the interviews I had, the market prices have come quite under pressure due to the increasing production volume. The markets that we see from these discussions that are expected to show the strongest growth is application in concrete and the urban soil applications, which is why I highlighted them in the introduction. And then the replacement of fossil carbon in metallurgy is also becoming increasingly relevant for many of the producers. Again, not carbon removal, but pays fully into the topic of emission reduction. And well, two more trends that we still see quite a number of new industrial players entering the market. Interesting. We see that agricultural residues are increasingly becoming relevant. And we started to survey also the feedstocks, and we'll probably next year also publish how the feedstocks split over the production capacity. And last but not least, valorization of surplus energy, which is what I showed in the energy in the net zero pathway, is very clear that without a very good valorization of the energy, it'll be very difficult to have commercially viable projects. So with that one, I want to quickly skim through the reference projects we selected as representative and nice and interesting projects, starting with Energy Ocean System, Biomacon, last year installed, feeding the excess heat into the district heating network. A system in Italy, they're using prunnings from fruit orchards with a Biochar system. Interesting heat application is for it's for thermal. It's used for cooling system, 400 tons biochar. We have the Novocarbo system in Grevemühlen or Baltic Sea, with also a local district heating network, but also producing electricity aside to the carbon removal element. We have, for those of you who joined our Biochar Summit in June last year in Helsingborg, some of them might have seen the system of NSR. It's a VAU-ASA system where municipal green waste is used to produce biochar, 1,200 tons, but also to produce surplus energy to feed 1.5 megawatt thermal energy into the local district heating network, which is something very much common in Sweden, the district heating networks. Then another highlight project, the project of Sonnenerde with an NGE system using agricultural residues and municipal green waste. Very interesting energy use is drying of sewage sludge with an excess heat usage of 250 kilowatt for the feedstock drying 700 tons of biochar produced. Another project by Salzwerke in Heilbronn with a Synkraft system producing 11 gigawatt hours of renewable heat that goes into the company-owned district heating network, and alongside producing 7.5 gigawatt hours electricity, biomass being used, residual forest wood, and biomass from roadside landscaping. And I think not the last project. Wow Green Metals feedstock is here, demolition wood, and same here, feeding up to 2 megawatt thermal into the local district heating network, and alongside with producing biochar, mostly being used to replace fossil coal in the metallurgical industry. And this is our last example from Stisdal in Denmark. That project is currently under commissioning. It uses as a feedstock biogas digestate, and alongside producing 7.5 megawatt thermal, high temperature, that is being used to upgrade biogas into the gas system. And this is quite a large project with 15,000 tons annual production of biochar. So the purpose was to show on these projects really to show that today's commercially viable projects have a huge element of energy into the system. Now, coming to the scaling of the industry, and some of you might know these considerations. It's all about scaling the growth rates in industries. And we saw photovoltaic was always the leader in growth rates, and it's pretty challenging to achieve high growth rates, what we see when we look at wind industry, concentrating PV, nuclear, or biomass electricity. Now, so far, BCR has really shown a strong track record. And this is just to repeat the previous growth rate numbers we saw in the report, now just converted from biochar produced to amount of CO2 captured with BCR. And now we look into a scenario, okay, what happens if we can maintain a 50% growth rate? Well, in that case, we can get to 2.3 million tons by 2030, which is almost exactly or just under 50% of the ambition of the European Commission for technical permanent carbon removal. So it doesn't seem to be, or it seems to be achievable, this target. Now, moving from 2030 to 2040, and assuming that what we saw in the solar industry, that growth rates might decline. If that happens, we'll end up at 50 million tons of CO2 by end of 2040. If we look at an upside scenario with slightly higher growth rates, we would end up at 80 million tons by 2040. Now, the numbers have to be compared or seen in front of the EU target, which is 75 million tons of permanent technical carbon removal, and with the overall target of 400 million tons for all CDR solutions. And we have to see them in front of a target to cut emissions down to roughly 490 million tons. So the range between 40 and 80 is quite relevant. Now, once again, looking at how realistic is that? So looking at the number of installations that have to be made. So this is new installations that have to be made to achieve the 2030 target of 2.3 million tons. And so there was 300 in 2030, new installations. Or looking at the cumulative installations, we would have to bring the total installed number from today 71 to 1,250 plants by 2030, or equivalent to a growth rate of 33%. Now, when we look at the bottlenecks of the above growth rates, I would say, could the industry produce enough equipment? Can we to support this growth rate? I would say yes. That seems perfectly achievable, this growth rate. Next question is, can project development and permitting and project financing facilitate such a growth? Well, that we need more of professional project developers and people that want to enter the space to provide financing, project financing. But yes, I don't see that this would be a limit. The question on the biomass, very often asked, well, at least until 2030, 2040, I think it's a question of allocation. And does the allocation make sense? Yes. In the context that we see that BCR shows higher net CO2 effects than mere combustion, I would say the allocation makes sense. And overall, the 75 million tons would require something like 15% of the energetically used biomass. So it doesn't seem to be unrealistic. And last but not least, can the markets for the carbon preserving applications grow fast enough to take up the produced biomass? And I would say that this is probably the biggest challenge to achieve the high growth rates. So what if the whole establishment of the offtake markets would take longer, more time? Well, then this could, for example, result in an alternative growth scenario, which would then stay at 40%, and maybe even later in 2030, when we see that we need to provide more carbon removal, that might even grow back again to the 50%. But also in this alternative scenario, BCR would be in the range of 40 to 70 million tons of permanent carbon removal. Which brings me to my last summary slide, which is, yes, I do think it is reasonable and realistic that BCR can deliver carbon removal at climate relevant volumes within the next 15 years. And I'm really looking forward to working on this together with you, together with our members, together with all the stakeholders that are around in this space. So thanks a lot for your attention. Please, we don't have too much time anymore for questions, but still, Harald, you might want to come up with a few questions. But last, I want to share this final slide. So if you like the report, if you find that helpful, if you are a commercial actor, we're writing this report to be read. And but if you're a commercial actor and if you're not yet member of EBI, we'd like to invite you to join EBI as a member, or to make a voluntary one-time contribution to our work by signing up for an invoice of 500 euro. Thanks a lot.
So thank you, Hans-Jörg. It's indeed, we don't have too much time left, but I think it was also important to take a bit of time to report on what we have elaborated here, which is really a tremendous piece of work. So thanks, I liked it a lot, and particularly the energy perspective and the different scenarios of realized carbon removals, I think is extremely helpful. And the latter, of course, also depends on the legislative framework, and so we do have the choice, and we're doing what we can in order to facilitate a framework which leads to a rather steeper slope and a quicker carbon removal action, bringing it to volumes. So we have a couple of questions. I would just give you the choice which one you want to answer, but I can also just start on the top.
Please pick, and I
of course. So the first one would be about concrete, how you come to the conclusion, let's say, that the concrete or cement would be the next best thing. I don't read the entire question. I think
Yeah, well,
that should be enough.
I'll be quick because I've seen many results, many promising results. It's a very effective way of reducing the carbon footprint of carbon in a relatively inexpensive way. And there's very solid and very good results from various players that show that you can even, with the right biochar, the right way applied, you can even improve the properties of the concrete.
This is also what I think is extremely interesting. Make much better products by adding this source of carbon. The next one would be, I have to read parts of it at least. It's about the pyro and power. And I don't know if what you meant with pyro and power was exactly understood in the right way, but maybe yes. Like pyrolysis oil has not yet been proven to work without problems in engines or turbines. Yes, of course, it's way too much.
No, it's gasification. It's gasification
molecules.
or ORC. These are the two approaches that are today market proven, and which I see representative for being. This is what we calculated in that study: gasification. Yeah.
Yeah. And then there's also a question I mean, it's part of the same one. If it's really good to use such a valuable product for aviation or such things, it just depends, right? And for shipping, for example, there are some options, some sectors where you don't have many options, and where it definitely makes sense to replace fossil carbon with biogenic carbon. But of course, also it can be a base chemical for the chemical industry or whatsoever. But I think that's also part of a different discussion. The next one would be interesting. Does EBI think that most of the entire European biochar production meets the financial additionality criteria of carbon crediting registries?
Oh yes, definitely, because I mean, I saw that in my previous life in solar. I mean, market growth will only happen if prices come down. That's very clear. And what we clearly see now, that part of the growth is really, and it's not black and white. I mean, there are applications of biochar where there are customers that pay a very high price, but this is not volume suitable. If we want to go to volumes, the prices of biochar need to go down, and then the carbon removal value needs to be monetized. And if it doesn't happen, these projects will fall apart. Clearly, most of the projects will fall apart without the carbon removal credits.
Yeah, and that will of course have an impact on the growth trajectory and the carbon removal potential. Another one about sustainable biomass. Yeah, of course, biomass is limited, and how to produce 80 million tons of biochar. Maybe a quick remark to that: feedstock variations.
Yeah, I mean, I mentioned in the report the huge advantage of biochar is that most of the systems are in the range of 1,000 tons to 5,000 tons of biomass feedstock, and in a way, the logistics for this kind of sizes are moderate. The requirements for logistics for these kinds of systems are moderate, and therefore, in a way, the competition is either not collecting the biomass, which is typically done by roadside landscaping. Go when you're in the car at the autobahn, you will see a lot of wood chips just chipped under the trees, and this will be CO2 in less than 2 years, all of it. And therefore and I've seen that in solar. I mean, the beauty of modularity or decentralized systems is it can grow faster than large centralized systems, because financing is easier and logistic approaches are easier. And therefore, I think, and once again, it's not black and white. We have to stop thinking that something is black and white. And there are definitely use cases where using biomass for heat production makes also sense. But it is an additional BCR, is an additional kind of wrench in the toolbox of finding the solution, and therefore, yeah, maybe that's everything from in short.
Yep. So there's quite a number of underutilized biomass still available. Also biomass which is currently not being used for other purposes. Okay, and of course this question also addressed the biomass has to be used for heat, electricity, and biofuels. I mean, that's what is being done actually. There is heat being produced by pyrolysis, in several occasions also electricity, and it produces a valuable carbonaceous source. So if it's biofuels or some biogenic carbon, which will be then used for other purposes, I think that's addressed. Hans-Jörg, do you want to say something about the carbon credit pricing, because there's a question addressing that and the trend?
The trend. A good question. Well, first I would like to refer to Poor Earth system of they have a, I don't know the right term for it. They have a market price index. That's the term. Poor Earth has introduced a market price index, which I don't know exactly where it stands today. When I last looked at it, was around 130 to 140, 50, something like this. And I think this is a realistic price, what can be calculated today. I would hope it would remain there or go slightly up. I think we should not dream of that going up to 200, beyond 200 euros. But to be very clear, and it was kind of raised in the question before on financial additionality, if there would be kind of a decision that the carbon credit price for biochar is 100, then we will get a certain growth rate. If someone else, I mean, if the European Commission would say, you know what, the carbon price for carbon removal is by law now 200, then we'll get a different growth rate, very clear. And so there is no wrong and right. I personally believe that a price between 150, 175, 200 would do the job to scale biochar carbon removal to 75 million tons by 2040.
Thanks a lot. So we're basically at the end. I just see a comment of Paul Smith. If the use of sewage sludge would be a good feedstock, of course. And we're just writing a paper on that, which will be out also by next week. 1.5 million tons of sludge per year in the UK alone. So it's, I think, 10 million tons in the EU that we could use. Not all of it, of course, for the same purpose. Some of it is contaminated, which has to be used, treated adequately and used adequately. Hans-Jörg, thanks a lot. We're at the end of the time. Thanks for this elaborate insights. There are certainly a couple of questions that we didn't answer, but I think it's a very good start. And the report actually does contain a couple more slides and a bit more elaboration on certain topics. So that was the presentation version of it. So most of it can be looked up. Tremendous work. Thanks a lot. And thanks everybody for being here. We've had almost 200 people joining, which for a webinar, I think that's quite something. So really happy about this. Thanks a lot for your interest. And well, the next webinar will be taking place tomorrow. If you have colleagues you want to have joining it. And well, download the report. It should be available. Check your spam folder. You know how those things work, but generally it does work. Thankful. Have a good rest of the week. Thanks a lot.
Thank you. Thanks for your interest. Bye-bye.